So in the last section of Chapter 10, we're going to talk about how to make sure that you're using T procedures wisely. There's two ways you can think of two sample T problems. So, should you use two sample T procedures with paired data? And why not? And how would you know? Well, here's some questions to ask yourself when you're looking at two sets of data. First of all, can you create a label for each row? Does each row represent one individual subject or one individual piece of land or something like that? If you can say yes to that, then it's a paired test, which means you subtract the differences and use the differences as a one sample t-test. If you say no, then you would do a two sample t-test like we've done in the second half of this chapter. Another question you could say is, would it mess up the data if the list was scrambled? If you say yes to that, then yes, you want to do the paired test, which means you find the differences and again use it as a one sample t-test. But if it doesn't mess up the data, then use a two sample. Now, what do I mean by that? Well, here's a couple examples. This is from a study done with calcium versus placebo and the change in blood pressure. And what I see in group 1 is there's so many individuals, and then group 2 is so many individuals. Well, they're all different individuals, right? So if I scramble this list right here, if I scramble up list group 1, it's not going to affect group 2 because these are all unique people. So because of that, that would be a two sample t-test. Now look at this one. This one has to do with depression levels, taking caffeine, and a placebo. And notice they subtracted here because these two values, however they measured depression, are connected to this one subject. So because my two sets of data are connected to one individual, in the case of subject, I would subtract and it would be a paired t-test. So I'd just do a one sample t-test. So suppose you're designing an experiment to determine if students perform better on tests when there are no distractions, such as the teacher talking on the phone. You have access to 2 classrooms and 30 volunteers who are willing to participate in your experiment. So A says, define an experiment so that a two sample t-test would be the appropriate inference method. So 2 samples, 2 unique groups having 2 different treatments. So here's how I would describe that. I would write A on 15 index cards, B on a different 15. Shuffle the cards and give 1 to each of the 30 volunteers. All 30 subjects will take the same reading test. A subjects will have no distractions and in a separate room. B subjects will have a proctor talking on the phone during their test. Then at the end, we'll compare the mean score for the A room with the mean score from the B room. All right, that's a way to do it with 2 separate samples and a t-test. All right, and B says, design an experiment using the same idea so that it's a paired test would be the appropriate inference method. So I really am looking at the difference of 2 results. So that means that every student would need to experience both environments. Okay? So how would I set this up? Well, using the same card procedure we used in A, I would randomly divide the subjects into 2 groups and give them all the same reading test. The group A's will start in a distraction-free room, and B's will start in the talking proctor room. After a short break, I'll give all 30 subjects a similar test in the opposite rooms. And we'll calculate the difference in the 2 scores for each subject and compare them with a mean of 0, meaning there's no difference in the distraction versus no distraction group. So hopefully you see that each individual is getting both treatments. That's what makes this a paired test. So part C, which experimental design is better, do you think? Well, I would say part B is better, the paired t-test, because it eliminates an important source of variability. That is the subject's reading skills, right? Better design will mean better power or more power in your test. So you know that some people read better than others. What if all the good readers ended up in the non-distraction room? That would skew your results a little bit. But if you do the paired test where their score is compared to themselves, that takes away that one source of variability. Again, it doesn't remove all of it, all variability, but that one source of reading skills could be eliminated. And then what's the purpose of the random assignment? Well, in part B, when we randomly assign them to rooms, You want to make sure that one treatment isn't favored by always going first or second. Sometimes maybe test fatigue sets in by the second test. Well, if everybody starts with one test and ends with the second, then you have that source of variability in there. But if we randomly assign them, then you have taken that source out. And again, better design, more power.